welcome to this class on circuit theory. In the last class we have seen what are the different properties of the network or circuit or two terminal element. Then we had a quick review on the basic terminologies which we will be going to use throughout this course. Now from this class we will start on the topic called circuit analysis, or I can call it as a network analysis also. So in order to do that, generally there will be the given circuit or the circuit will be given to you, which will consist of various circuit elements, that will be R, L, C, and also there will be so many sources, and the function of sources or the voltage source or maybe current source will be to deliver the energy to the source elements, to deliver the energy to the elements of the circuits. And what we have to do there, we have to find out the different or the various currents and voltages for the various branches, you can say, or for the elements. Okay, so this is the problem of analysis. Okay, so for this first we will just have the introduction on the sources. And sources, two kind of sources we will be going to use in this course. One is your voltage source and second will be your current source. Okay, and this both voltage sources and current sources will be fixed, or I can call it as a DC voltage source and AC voltage or current source. Okay, so if I am saying the DC voltage source where the voltage remain constant or the voltage will be fixed, so the representation for the DC voltage source will be like this. There will be positive terminal, negative terminal, okay, or something like this, positive, negative. Okay, so this is positive, negative, this is also positive, negative. And some value, suppose E, here also some value, let us say E. So when this symbol is used and when this symbol is used, basically this is both are my DC voltage sources, but this will be used when there will be low voltage ratings, and this symbol can be used when we will be using this for high voltage ratings. Okay, this is for the voltage source. And similarly for the current source, we can represent with this. So these are the two leads and that will be represented this way, okay, with some I value. So this is regarding DC voltage source. And if I would like to say AC voltage source, so it will be time varying voltage or current source, and the representation time varying will be sinusoidal. So the representation will be like this. This is for voltage source, and for the current source it will be something like this. Okay, now with this let us see some details on voltage source, or how we can represent the voltage source and current source, that is practical voltage source and ideal voltage source. Okay, so to study with, if I am saying the voltage source, means your voltage sources basically are DC voltage sources are nothing but the batteries. Okay, and if I am saying current source, basically current source is difficult to imagine. Generally current source is not available in shops. If you go to shops, generally they will be giving it as a voltage source, but voltage source can be used to act as a current source, so that we will see how. So basically a practical DC voltage source, let me draw, and basically practical voltage source means the in this practical voltage source there will be the resistance connected in series with the source. So let me draw that something like this, and there will be some internal resistance connected in series with the battery, and suppose that is E and R is the value, and suppose these are two terminal, let me represent with AO. Okay, so now if let's say through this your load resistance has been connected, fine. So this is my load, suppose, to the battery. Okay, so through this again what it will be, some I current is flowing if it is connected to AO, and if it is open circuit obviously I will be 0 because of the infinite RL. Okay, so this is basically the practical voltage source. Now let me write what will be the voltage between AO. So VAO will be, as already we discussed, if I would like to find out the voltage between A and O, it will be like this if the current is moving in this direction. So this will be positive and this will be negative. Okay, so what will be VAO? It will be E, and there will be the drop, so it across R, so it will be minus I into R. Okay, so what will happen in the VAO, which is the output voltage of the battery, will be always less than the specified voltage of the battery because of this internal resistance. Okay, this is the practical voltage source, and if I would like to say the ideal voltage source, then how will it be? It will be something like this. R is connected in series with it. Sorry, for ideal voltage source there will be no R, no internal resistance, it will be simply connected to RL, E, and the terminal, suppose it is A and O. So what will be VAO in ideal voltage source? It will be as good as here E. Okay, so in this, no matter what the value of I is, voltage will remain constant for any value of I. But in practical voltage source, what will happen? Condition will not be same. It will not be constant. Okay, so let me draw the VI characteristic of for this. Suppose this is I, and say this is my VI characteristic. So in ideal voltage source, what we will get? We will get it the constant voltage source, which will be value of E. But in practical voltage source, the condition will not be same. There will be some drop across internal resistance like this, and output voltage will be this much. This much will be your VAO, and this will be your drop across internal resistance. Okay, but in if you look at this ideal voltage source, you will get it the fixed amount of E, whatever may be the current. Okay, but it is not true for the practical voltage source. There will be some drop. Now you can, this is I into R, so you can see here, if value of R is more, then what will happen? This drop will be more, and whatever the obtained output voltage from the battery will be very less, so which is not good. So in order to have the good, in order to get the good amount of output voltage from the battery, what should be the case? Your R, that is internal resistance, should be as small as possible. Okay, so this should be the case. Now this is all about the voltage source. Now let me talk about the current source. Basically we are not used to current source generally, from where current source came basically. Okay, so but we can have the current source from the battery or from the DC voltage source. So let us see how can we use the battery also as a current source. For that, let me draw the practical voltage source like this with value E. There will be some internal resistance R, and these are the output terminals of the battery. And to this, if through switch, if I am connecting the load resistance like this. Okay, so as we know, if switch is open, so in this case what will happen, your RL will be infinite and current will be 0. Okay, but now if I would like to make it as a current, so what I will do, I will make it switch S, let me call this switch S is closed, so that now current will flow inside of it. Now with this load is connected as we have seen. Now if this is the case, then what will be, or how much is the current flowing in this circuit, so that you can find out using, let me write here, using like this. I will be your voltage which has been supplied by battery is E, and total resistance which is R plus RL. So this much amount of current will flow when the switch is closed or when the load will be connected. Okay, now let us apply some sophisticated mathematics here, so that for my convenience, so for that let me divide numerator and denominator by small r, so it will become E by R divided by 1 plus RL upon R. And if you look at this carefully, what is my E by R? Let me write here, what is my E by R? This is basically, the current, and or I can say this is the property of battery or property of source, which is nothing to do with the what kind of load I am connecting here. Okay, so basically this value will be decided by the battery. Okay, and this E by R, I can call it as the short circuit current. And what it will be, how it will be, this will be E, there is R, and if I do the short circuit, I'll get it, this value E by R. Okay, and that I will call it as the short circuit current, which will be E by R, and which will be the parameters of the battery, or which will be the property of battery source, you can say. Now we can observe that ISC will be fixed because of the fixed value of E and R also. So with this, now this I can write it as this I can write it as E by R, which we have declared as ISC upon 1 plus RL upon R. And let me solve this, so it will be short circuit current into R divided by R plus RL, which will be my I. Okay, so then let us look at this equation carefully. What is this basically? If I have two resistances in parallel like this, suppose this is my R1, this is my R2, and I amount of current is flowing through it, and this will be again my I. This is my I1, and this is suppose my I2. So if I would like to calculate, for example, I1, and suppose you know I, R1 and R2, so you can use the current division rule. We know it. What will be I1? I1 will be total current into opposite resistance divided by sum of the resistances for which I would like to do the current division. I would like to find out the current in that particular branch, divided branch. Okay. So if you observe here, what is it? This will be the sum of two resistances into opposite resistance. So it is as good as same. Okay. So what can we interpret from this equation? That this also I can represent in circuit representation. So this ISC will be your total current, and this R and RL must be in parallel in order to have the current source. Okay. So suppose this is the direction of my current source ISC, and to that this is flow of current, and then here suppose this is my R, which is the internal resistance of the battery, and to that we are connecting the load resistance RL. Okay, so that what will happen, this will be my I. Okay, which is this, that is the current to the load, which will be equal to total current Is into opposite resistance divided by R plus RL. So that ISC we know can be generated from the current source. This okay. Whereas if R is the smaller, then what will happen? Current will be this much, and this R is basically as small, and that will be decided by the battery specifications. Okay. And this will decide the direction of current of the current source. Okay. So with this, now what I want to say, if it is a voltage source or practical voltage source, how can I look this? This will be DC voltage source, and there will be internal resistance connected to it, E, this is R, and RL will be connected to it. And if you look from this, what it will be AO, VAO will be E minus I into R. Okay, this much you will get it. Whereas if it is an ideal current source, then what can be done? This will be E by R will be giving me the current source, which will be ISC, and then two resistances which are in series can be connected in parallel, which will be R and RL. Okay, and this will be my VAO. Okay, so ideal voltage source will be simply this terminal, ideal current source will be like this, and if it is a practical voltage source and current source, this is my practical voltage source, and this will be practical current source. Okay. So battery can be used as a voltage source, and it can also supply current, so that it can also be act as a current source. And what will be the characteristic of the current source, that is VI characteristic? It will be ideal current will be constant, whereas in practical source it will be something like this for any amount of voltage. Okay. So this is basically regarding the voltage source and current source. Now we know there are various the components which will be in the circuit, and the essential thing is to find out the currents and voltages for various branches, to solve the problems, and that will be centered around two laws, that is called the Kirchhoff's voltage law and Kirchhoff's current law. So these are two essential laws that we should know in order to understand the circuit theory. And just we know it overall, what is Kirchhoff's voltage law? In any circuit, the algebraic sum of all voltages in the loop will be equal to 0. Okay, so I will be number of branches. Similarly, Kirchhoff's current law will be in the junction. For the junction, all the currents, either incoming or outgoing, so algebraic sum of all the currents at a junction will be equal to 0. Okay, so if you know KVL, that is Kirchhoff's voltage law and Kirchhoff's current law, enough for you to do the circuit analysis. With the help of Kirchhoff's voltage law and Kirchhoff's current law, you will be in a position to calculate or to find out the voltage and current in any branch. Okay, if you don't know that. Okay, so KVL and KCL are enough for you to obtain the voltage and current in any branch. Okay, but it may be tedious. That's why other tools have come, or other methods have come. Okay. So for this, let us see the KVL and KCL with one example. So to see that, let me draw the network. Something like this. There is a resistor here, one more resistor here, and one more resistor here. This is the battery of, let's say, put it any number which is 20 volt. Suppose this resistor is of 0.4 ohm, this resistor is of 2 ohm, and this resistor is of 8 ohm. And it has been asked you to find out all the currents, voltages, and also do the power balance. Okay, so to do it, let us first find out the polarity. So suppose this is my battery, through that this much current is flowing, I, coming I here, then it is dividing here. So suppose this is my I1, I2, as current flowing in this direction, so this will be my convention for the polarities for the potential difference for this current flowing this way. So this will be my potential difference, this will be the polarities for the voltage. Okay, and let me name it for my beta side. So suppose this is O, A, B, C, D, or any name you can go, O, A, B, C, D, and suppose this is E. Okay, so now in order to find out the currents and voltages each branch, let me name it. This is suppose V1, V2 drop, and this is my V3 drop. Okay, so first what I know total voltage. So let me obtain the total current first. So how to obtain the total current? For that I should know total equivalent resistance, and we observe that 2 ohm and 8 ohms are in parallel. So 2 ohm is parallel with 8 ohm resistance. So what will be the equivalent resistance for it? It is 16 plus 10, which is 1.6 ohm, and then it is in series with 0.4 ohm. So total resistance will be 0.4 ohm plus 1.6 ohm, which will be 2 ohm. Now I know total equivalent resistance, I know total voltage, so I can find out the current as V by R, which is 20 divided by 2. So total current will be 10 ampere. So now I know this is my 10 ampere current is flowing through this branch. Now this current will be definitely going to divide into two branches. One is this, second will be this. So for that, let me calculate what is the value of I1. So I1, so to obtain I1, what can be done? I can use the current division rule here. So for that I need the total current, which is 10 ampere flowing here. So it will be 10 into opposite resistance, which is 8, divided by the sum of resistances, that is 2 plus 8, which is 10. So it will be around 8 ampere. And similarly I can calculate I2 either using the same rule, current division rule, or I can use the the KCL and find it out that. So let us see, I2 will be 10 into this much is opposite is 2 divided by 2, so which will be 2 ampere. So this is, if I1 is 8 ampere, remaining will be 2 ampere will flow in this branch. Okay, now I know the currents for each branch. Now what I will do, I will calculate the voltage drop across each resistance. So here V1, so V1 will be how much the current is flowing, that is 10 into resistance is 0.4, so it will be 4 volt. V1 will be 4 volt. What about V2? V2 will be 8 into 2, so this will be 16 volt, and V3 will be how much? It will be 8 into 2, so this is also 16 volt. Okay, so let me write on the network, this is 4, this is 16 volt, and this drop is also 16 volt, not ampere. This is 16 volt. Okay, now I know current, I know voltages for each branch. Now let us check it out whether really KVL and KCL satisfied or not. So first let me check it for KCL. So in this, to check it out, let me take it to the convention, and this convention I will use throughout this course, and this is not unique. That convention you can choose it by your own. So suppose I am taking, this is my node. So if the current is coming to the node, that current I will make it negative, and if it is leaving, that current I will take it as positive value. Okay. And for KVL, if I am going from negative terminal to positive terminal, voltage I will consider as rise, and if I am going from positive terminal to negative terminal, I will consider voltage as drop. So these are the conventions I will follow. Okay, so with this now, what next I have to do? Yeah, I have to check it out for KCL. So let me apply KCL at this particular node. So coming is minus 10, outgoing currents are 8 plus 2, so which will be 0. The sum of algebraic sum of all the currents at junction is 0. So KCL satisfied. In order to satisfy KVL, you take it any loop. Suppose I am taking the loop O, A, B, C, O. So do the algebraic sum of all the voltages. So if I am starting from O to A, what is happening? Voltage is rise. So it will be 20. Now I am going from A to B. There is a drop of 4 volt. So it will be minus 4. And if I am going from B to C, again there is a drop of minus 16, which will be equal to 0. So KVL satisfied. Even though if I am taking this loop, let me start from C to B. So C to B is 16 voltage rise, because as we have decided, negative to positive if I am going, there will be rise, positive to negative there will be drop. And from B to E I am going, there is a drop of minus 16 volt, and this is simple wire, so voltage will be 0, so it is again 0. If you take it this also OA like this also loop, it will satisfy the KVL. Let us check it. From here 20, this will be minus 4 and this will be minus 16, so always this will be also equal to 0. Okay. Now next what we'll do, we will have the power balance also. Let us check it out whether it conserves the power balance, it conserves the energy or not. Okay. So in order to do, first we know if the power will be positive, then it will absorb, and if it is a negative, then it will be delivered. And how to do the conversion also? If I am going from the positive terminal, then you take it that power as the delivered power, and if it is going into it, then you take it as a absorbed power. Okay. So here what I am saying, current is flowing from positive terminal of the battery. So this battery source will deliver the power. So let me calculate the power delivered by 20 volt battery source. Can be calculated in the product of voltage into current, that is 20 into current is 10, so which will be 200 watt. Now let us come to this. So here current is coming into the positive terminal, so this element will absorb the power. So power absorbed by 0.4 ohm resistor will be VI, so it is 4 into 10, so this will be 40 watt. Then power absorbed by 2 ohm resistor will be 16 is the voltage drop into 8, so 16 into 8, it is around 128 watt. Again, what next? Power absorbed by 8 ohm resistor will be, how much is voltage drop? It is 16, current flowing through it is 2, so it will be 32 watt. Now let me check it out whether power balance is there or not. Means what? Power. So let me do some remarks. So it will deliver the power, this will absorb the power, this resistor as it is going in positive terminal, this will also absorb the power as current is going in positive terminal, this is also absorb the power. Okay, so power delivered we should be equal to power absorbed. So power delivered is 200, power absorbed is 40 plus 128 plus 32, so it is 128, this is 130, 160 plus 40, so it is 200. Okay, so power delivered is equal to power absorbed, or sum of all the powers is 0. Okay, so with this power balance is there in the network. Okay, so thus total power delivered is equal to total power absorbed. Okay, so the point to notice here is that in any circuit or network, KVL and KCL must have to satisfy, and it must have to satisfy all the time, and power balance also must have to be there. Okay, and if you know that instantaneous voltage and current, you will be able to know instantaneous power also. So from that we can make a conclusion that for a given network or circuit, doesn't matter whether it is R, L or C, always I came to know that here all the currents, if I know all the currents and voltages, then KVL and KCL must have to satisfy, and also power balance must have to be noted. Again, one more thing here for the source which we have delivered, it's not necessary that all the sources will deliver the power. Some of the sources may absorb the power also. So convention we make it that if it is current is going from positive terminal, then deliver the power. If it is current is coming into the positive terminal of the battery, then it will absorb the power. Okay, so that we just want to make a point on it. Okay, now one more point I would like to mention here is that how to calculate the potential difference between 2 points. So let me take it other way also. One of the way also to calculate the voltage between the 2 points. So let me take it the same circuit. Okay, this was 20 volt, this was 0.6 ohm, this was 2 ohm, and this was 8 ohm, and already this current we have obtained, which was 10 ampere. This voltage drop we obtained is how much? It was 4 volt. This was suppose V2, and this is suppose V3. How much it was? 16 volt, and this was also 16 volt. Okay, and let me name this O, A, B. For example, this is C, and D and A, because all these are connected to the wire, so let me name it O. Okay, now suppose I would like to find out the potential difference between this point VBO. Okay, and I know this drop, I know this voltage, so no need to calculate with the I into R. You can directly calculate using KVL how it is. For example, if I would like to calculate from the voltage between point B and O, then what you do, you start from point O and reach to point B, and from O you are starting, so whatever the voltage drop or voltage rise will be, you just add all the voltages, and resultant will be nothing but the difference between B and O. What I mean, I would like to calculate the voltage between point B and O. So you can, in order to calculate that, you start from point O and reach to B, either in this direction or in this direction. Both the values will get it same. For example, and sum all the voltages. For example, if I am going from this, if I would like to calculate the voltage source between point B and O, so VBO will be equal to, let me start from this. So here if it is a wire, 0. Okay, now from here to here, what is happening? There is a voltage rise, so that will be positive. Now I am going from A to B, so what is happening? Positive to negative, this is -4, and yeah, I reach to B, so whatever the total value you will get, which will be 16 volt. Okay, suppose if I am saying BO, in order to calculate, start from point O, reach to B, and add up all the voltages. Resultant will be the voltage difference between B and O. Suppose I would like to go from this, so what it will be, VBO from here to here 0, as it is a wire, from here to here also 0, from C to B, yeah, B I reached, but here what is happening, I am going from this to this, so there is a rise, voltage rise, so it will be 16. So if you compare this, I will get it the same value. Okay, so what I mean, no need to calculate again, do the calculation to compute the voltage between point B and O. Once you know this, you can do the algebraic sum of voltages, and you can find out other voltages, other remaining voltage also, using this particular strategy. Go from the second point, I mean go from, if I am writing A and B, go from point B and reach to A, and add up all the voltages. Okay, so this way also you can do. With this, we stop here. Next class, we'll see again two more examples to clear the power audit and how to find out the voltage and currents for various branches. Thank you very much.